Today we're going to look at electric charge and current. First of all, let's define what charge is. Charge is the amount of electricity traveling through a circuit. And charge is measured in coulombs, so units C, capital C. I want to ask a question now. What is the rate of flow of charge? Is it voltage, current, or resistance? Okay. Hopefully you guys know that current is the rate of flow of charge, and that is in units amperes. Okay, now let's move on to a new equation. Q is equal to I times T. That's essentially what I've said here, because charge is the amount of electricity traveling through a circuit, and we know that the rate of flow of charge is current, so Q is equal to current times time, charge is equal to current times time. And over here I've just done a quick symbol and unit check. So Q is charge, has the unit coulomb, I is current, has the unit amps, T is time, has the unit seconds, R is resistance, has the unit ohms, V is voltage, and has the unit volts. Okay, so let's move on to the ingredients for an electric circuit. So there are three things you need. You need a source, so voltage or potential difference. Well, voltage is the same thing as potential difference. You need some conduction paths, so you need some wires to link up one place to another, and you need a load, so something that uses the electricity, so it could be your resistor, your lamp, whatever. Okay, we're going to have a little quick recap on Ohm's law. Remember that the relationship between voltage, current, and resistance is written by that. And here I have my little circles again, and this red bar is trying to represent my resistance. And if I have a small red bar, I have a lot of current flowing for a given voltage. But if I have a really big red bar, so a really big resistance, I have a really small amount of balls on the right-hand side. So I have a small current. So for a given voltage, if I increase the resistance, if I increase the length of this red bar, my current is going to decrease. And yeah, so that's how we use Ohm's law here. Now I'm going to give you an example / question. Okay, so here's your circuit. It's in series. Remember, in a series circuit, potential difference is shared between X and Y. Where in a parallel circuit, potential difference is the same, but current is shared. So current is the same in a series circuit. So I want you to pause the video and try to calculate the potential difference / voltage across X using Ohm's law. Remember, this is Ohm's law. Okay, hopefully you guys have unpaused the video now, and you've noted that the potential difference across X is given by, you have 2 amps, you have 3 ohms, so 2 amps is the current and 3 ohms is the resistance. You're going to have 6 volts, because this is the total potential difference. The potential difference across X is going to be your 2 amps times your 3 ohms, which is your 6 volts. Now, just as an added extension, I want to work out what the voltage of Y is. So the voltage of Y is going to be my 18 volts minus my 6 volts calculated here, because potential difference is shared, so the sum of these two things should equal my total potential difference. So 18 minus 6, I should have 12 volts across Y. If that makes sense, let me know. If it doesn't, also let me know. But yeah. Okay, let's move on to using this equation here. So remember, charge is equal to the current multiplied by the time. If I have a bulb and it has 1.7 amps, so that's the current of my light bulb, and I know that it's working at this brightness for 30 seconds. I want you guys to stop, pause the video, and work out what the charge is using this equation. Okay, hopefully you've unpaused the video. So charge is current times time, 1.7 multiplied by 30, that's 51. 51 watt, 51 coulombs, because it's in charge. Hopefully that makes sense. Thank you for watching it. Remember, you get one of these sheets if you want to take a look at it before your exams, or if not, whatever. But yeah, hope that makes sense. Bye.